Every star carries a secret. It is born in fire, burns in brilliance, and one day it must die. But not all deaths are the same. Some fade quietly, whispering away their last light. Others explode in fury, scattering their ashes across the galaxy. And a few, a rare few, collapse inward, falling so far into themselves that they create something the universe itself struggles to describe. A black hole. To understand how black holes are born, we must first understand that they are not monsters. They are not cosmic traps waiting to devour. They are the natural consequence of time and gravity, the final breath of a massive star. Every black hole began as something beautiful, a star that once shone, warmed, and gave light to its corner of the cosmos. Its end is not a failure. It is the universe folding back on itself, recycling matter and energy into something new, something profound. When a star dies, it does not disappear. It becomes the most mysterious object in existence, the point where space and time themselves seem to stop. Before we journey into the stars, take a moment. Subscribe and join us, because the universe is vast, mysterious, and full of stories waiting to be told, and you don't want to miss a single one. Long before a black hole is born, there is a birth, that of a star. Deep in the cold dark between the stars, clouds of gas and dust drift for eons. They are patient, invisible, waiting. Then one day a spark, a disturbance. Gravity begins to pull the cloud inward. The gas thickens, warms and spins. A core forms, glowing hotter with every heartbeat of collapse. And when it reaches the right pressure, the right temperature, something miraculous happens. Hydrogen ignites. A star is born. For millions, even billions of years, it burns steadily, turning hydrogen into helium, releasing light and warmth that cross the galaxy. In its prime, the star is a delicate balance between two forces. Outward, the power of fusion pushes. Inward, gravity pulls. These two forces hold each other perfectly in check. The star's heartbeat, its rhythm of existence. But that balance cannot last forever. Fuel runs out. The fire begins to dim. And when it does, gravity, that patient sculptor, takes control again. For small stars, the end is gentle. They swell into red giants, shed their outer layers, and leave behind a faint ember, a white dwarf glowing softly in the dark. But for the giants, the truly massive stars, 10 or 20 times the size of our sun, the story is very different. When their fuel runs out, their cores can no longer hold back gravity's pull. The star begins to implode. The outer layers fall inward at astonishing speed, crushing the core tighter and tighter. In moments, the pressure becomes unimaginable. The atoms themselves begin to collapse. Protons and electrons fuse into neutrons. And then, the core snaps. A shockwave ripples outward, tearing through the star. For a few seconds, it shines brighter than entire galaxies. We call it a supernova, one of the most violent, spectacular events in the universe. But what's left behind after that explosion is what truly matters. Sometimes the crushed core stabilizes as a neutron star, an object so dense that a teaspoon of it would weigh more than a mountain. But if the star was massive enough, gravity doesn't stop there. It keeps pulling, keeps collapsing. The matter falls inward until it passes a point of no return. That's the moment a black hole is born. When a black hole forms, there is no explosion, no light, only silence. Everything that was once the star, all its mass, all its matter, falls inward beyond a boundary we call the event horizon. Beyond that horizon, nothing can escape. Not light, not sound, not time. It is the ultimate one-way door. To an outside observer, it looks as if time itself slows near that boundary. A falling star seems to freeze, stretched by gravity, its light dimming until it vanishes completely. But from the star's point of view, it continues falling, deeper and deeper, until everything, space, time, and matter, compresses into something infinitely small. We call that the singularity, but that word hides our ignorance. No one truly knows what lies there. The equations of physics stop working. Space and time stop making sense, and yet somehow, this broken place becomes one of the most powerful engines in the cosmos. Paradoxically, black holes reveal themselves through light. When they feed, when gas and dust spiral toward them, they form glowing disks hotter than any furnace. Matter whirls at near light speed, colliding, compressing, radiating. To look at an active black hole is to see the universe at its most extreme. Bright jets of energy shooting from its poles, reaching across thousands of light years. Entire galaxies can be powered by such outbursts, and yet, at the center of that brightness, there is perfect darkness. Black holes are not empty. They are not holes in the usual sense. They are regions of space where gravity has folded reality so tightly that escape becomes impossible. They are the scars of creation, places where matter has been pressed back into the mathematics that birthed it. In a strange way, black holes are part of the universe's recycling system. When a massive star dies, it doesn't simply vanish. Its death sows the seeds of new worlds. The supernova that precedes a black hole scatters elements, carbon, oxygen, iron, into the interstellar medium. Those elements become the building blocks of planets, of oceans, of life, and the black hole that remains continues to shape the galaxy. Its gravity stirs nearby clouds of gas, triggering new generations of stars. Every black hole in its silent hunger contributes to the ongoing cycle of birth and death. It is both a tomb and a womb, an end that allows beginnings. At the center of almost every large galaxy, including our own Milky Way, there lies a supermassive black hole, millions or even billions of times the mass of the Sun. Our own is called Sagittarius A, a name that hardly captures its majesty. It sits in the dark heart of the Milky Way, 27,000 light-years away. For most of human history, it was invisible. Only recently, with the Event Horizon Telescope, have we glimpsed its outline, the faint glow of matter circling the void. How these giants form is still a mystery. Perhaps they began as smaller black holes that merged over time. Perhaps they were born in the early universe, when stars themselves were more massive and chaotic. Whatever their origin, they hold their galaxies together. The stars of the Milky Way orbit Sagittarius A, like dancers circling a silent conductor. Without it, the galaxy would be less organized, less stable. The black hole is not just a destroyer, it is an anchor. Every black hole is a challenge to our understanding. When we try to describe what happens inside, the math turns against us. The laws that govern everything else, from falling apples to orbiting planets, collapse under their own weight. Einstein's theory of relativity describes how gravity shapes space and time. Quantum physics describes how particles behave at the smallest scales. But inside a black hole, both theories apply, and both fail to agree. It is here, in this clash, that the next great discovery may lie. Some physicists believe that what we call a singularity is not an end, but a transformation, perhaps even a doorway, a place where matter is reborn, or where new universes might bud from the old. We don't know, we cannot see inside. And yet, the universe keeps giving us clues, ripples in space-time, flashes of radiation, whispers from the edge of the abyss. When two black holes collide, the universe trembles. The merger releases gravitational waves, faint distortions in space itself, that spread outward like ripples in a cosmic pond. For billions of years, those ripples travel across the void. And then one day they pass through Earth, stretching and squeezing space by less than the width of an atom. In 2015, we detected them for the first time. It was the sound of two black holes colliding over 1 billion years ago. That discovery confirmed what Einstein predicted a century earlier. That space is not a static stage, but a living fabric, capable of vibrating, singing. We are, in a sense, listening to the universe breathe. Black holes may seem eternal, but even they have a lifespan. They do not live forever. They slowly lose energy through a faint whisper of radiation, predicted by Stephen Hawking. It's unimaginably slow. For most black holes, it would take longer than the current age of the universe for them to evaporate. But the idea is profound. Even the darkest objects eventually fade. Someday in the farthest future imaginable, When all stars have died and all galaxies have dimmed, the last light in the cosmos will come not from stars, but from black holes evaporating into nothing. The universe will end not in fire, but in silence, with the faintest flicker of heat as the last black hole exhales its final breath. And then perhaps the cycle begins again. To humans, black holes symbolize mystery, danger, and the unknown. But to the cosmos, they are ordinary as stars or planets. They are proof that gravity can sculpt the universe as surely as light can paint it. And there's a strange beauty in that. The darkest places in the universe are also the most illuminating. They show us where our understanding ends and where wonder begins. In their silence, they speak. They tell us that endings are not the opposite of beginnings. They are the same thing, seen from a different point in time. When we look at the night sky, we are seeing the universe as it was, not as it is. The light from distant stars began its journey millions of years ago. Some of those stars have already died, and among them, some have already become black holes. The sky we see is a cemetery of light, the ghosts of suns that once were. And yet, in their deaths, those stars have created everything. The iron in our blood, the calcium in our bones, the gold in our jewelry, all were forged in the collapse of massive stars. Without death, there is no life. Without destruction, no creation. When you trace the story of a black hole back to its beginning, you are tracing your own origin. You are stardust, forged from the ashes of ancient suns, shaped by the same forces that make and unmake the stars. If you could fall into a black hole, if somehow you could survive the journey, you would not feel an end. You would feel the stretching of time, the bending of everything familiar. Outside observers would see you freeze at the edge, your image fading into red light and then vanishing. But from your perspective, the fall would continue forever, into the unknown. What lies beyond, no one can say. Perhaps nothing, perhaps everything. Every black hole is a question written in the language of gravity, and so far, the universe has not given us an answer. We used to fear black holes, to see them as cosmic devourers. Now we see them as teachers. They test our understanding of space, time, and energy. They force us to rethink what reality means, and they remind us that even the most terrifying things in nature have purpose. The same gravity that collapses stars is the force that binds galaxies, that keeps planets in orbit, that holds our feet to the ground. Destruction and creation are not opposites. They are partners. Without collapse, there would be no birth. Without endings, no beginnings. The universe does not waste its darkness. It uses it to create new light. So how are black holes born? They are born when the universe remembers that everything that rises must fall, when gravity wins and the light gives way to shadow. But even in that shadow, creation continues. Black holes teach us that endings can be beautiful, that silence can sing, and that even the darkest places in existence are part of a larger pattern, the rhythm of life and death that fills the cosmos. And perhaps in their silence, they hold a message. That we too are part of that rhythm. That every ending we fear is just another beginning waiting to be understood. Look up at the night sky. Somewhere out there, a star is collapsing. Right now in this moment. It burns one last time, bursts into brilliance, and then vanishes. And in its place, a black hole is born, a new mystery for the universe to tell.